Welcome to the second step in the morning presentations. I hadn't really looked at the title slide when I made a thought of this title, and as I typed it in, I thought it does look a little bit strange together with the ship, but there you go. Gita talked about the things we've been doing with cross-platform and so on, and traditionally, the last several years, I've done a presentation that has these 3 bullet points: portability, performance, and functional programming. But I'm going to try and do something completely different this time. I'm supposed to be the Chief Experience Officer. I'm just going to give you a glimpse of what I think the future user experience might look for, particularly for new users and people trying to get on the cloud. There is, however, the obligatory roadmap sign. This is one I've used before. Though as we go to cloud computing, of course, we're going to need different kind of maps. So there's a few new things you need to learn, but don't worry, the things that you know are still there. Everything you know still is. So LO-skolen, for example, is up there on the new maps as well. Anyway, enough of that. So I'm going to mainly do a demo for the next 25 minutes. I'm a little bit worried because the last rehearsal I did, everything just worked. So we could be in trouble now. But I'm going to imagine spending a bit of time with a young data scientist. I'm going to call her Mary. It's not Suki here, who was an intern, our intern in 2015. She spent some time with Roger. She's now gone off to study mathematics. But maybe when she comes back, she might be the person I'm having this imaginary conversation with. And she's been given a bunch of data to analyze. And she says, oh, my professor says you know something about this cool new language for analytics called APL. And I have this idea that before I start looking at these CSV files, I'd like to do something to figure out whether they are fake or real. And the first idea that popped into my head was I'd count the frequency of digits used in numeric fields to see if they have some sort of weird distribution, because that might indicate that somebody's typed them in. So for example, if somebody gave me this CSV file here, I thought it might be a good idea to maybe ignore the first digit in each number, then just look at the distribution there and count them up. And then if I had data like this, obviously there's 8 sevens in there. So somebody was, this data isn't right. And you know what? I can't find a Python library to do this. Can you help? And of course, rather than getting into a conversation with her about why there might not be a Python library to do this, I told her she came to the right place. And she should fasten her seatbelts. We'll go for a ride. Of course, she didn't recognize that symbol on the left. This is what fasten seatbelt sign look like these days. So let's switch to APL. And is the mouse working? Yeah. So I did notice a problem that the demo system seemed to have stopped working, just a minor, it's not working. I'm going to have to click. Right, so there's her file. She brought it along on a USB stick and gave it to me. Yeah, I'm going to have to do this by clicking. I don't know if anybody else, Dialog folks, Alt-N in bracket demo just stopped working this morning, and it's very mysterious. I hope it doesn't slow me down too much. So one of the recent additions to Dialog APL is this quad CSV thing, so I can read that straight in to a variable from the CSV file, call it fields. I can figure out which are the numeric fields by applying this validation, taking the first item of quad VFI, shows me where the numeric fields are. If I turn that into a vector, I can then apply that to the fields themselves. Oops. Yeah, this clicking is going to be fun. I can do the one drop each of the numbers, and I can extract the characters. So here are all the characters we want to do a frequency analysis of, and then I can use the new key operator to get a unique count. Now, they're not appearing in the correct order. They're appearing in the order that they appear in the data, but I have a little trick to do that. If I append all the digits to the front and do key, then I get the results in the order that they appear, which is now 0 to 9, except, of course, the result is 1 too high, but I can easily subtract 1. And there's the result that she was looking for. So then we can do some kind of variance analysis on that and decide that it's fake. So, that's interesting, she says, but what if the data's out somewhere on the internet? Well, then you have to load this little library tool that we have, HTTP command, and she says, I thought this crime data from Sacramento is one of the first things I need to look at. Can you get hold of that? Yes, I can do an HTTP command get, and here's the first bit of data for that. Okay, so this is looking interesting, she says, but I use Linux. I don't have a Windows computer. So can you help me get it onto my Linux computer and run it there? And so, okay, let me just tidy it up a little bit. So, as in any good kitchen, I've pre-prepared some things. So, in the folder, there's a function called foo. And I'm going to trace that. Give me a chance to show off the tracer as well. So, here's a variable. We do the HTTP command get. That returns about a megabyte of data. And then we go through the various bits, and at any time we can hover over here and see what's in our variable. And eventually do that last bit of code, and now we've collected it into a function. And here's the code that you want. All right. Why don't we create a GitHub repository so that we can share this data and work together? So we go off to GitHub, and we need to create a repository. We're going to call it D18Mary. We need to click on the new button first. It's important to do this when you create the repository, to add that README file. I'm not sure why you can't clone it if there isn't a README, but it's important when you do it, you go down here and click Create Repository. And then there's a README so that people can see what it is, and then they should be able to. Oh, hang on. Yeah, this is all wrong. This is what happens when you try and set it all up while you're sitting in the stands. To be better prepared and have the demo go more smoothly when you get to the stage. I wanted to do a Git clone. Right. And now back to my APL session. And now that I have that repository, which is just in a folder called, it's just a folder that's been created where the content's just containing the README, I can now continue and save that function that I wrote. All right, so I'm going to save my function foo into D18Mary noodle /foo and create the noodle directory because it isn't there already. And then I'm going to create a folder in there called demos. I'm going to create some data. In fact, there are two files that we might be looking at. And I'm going to use the quad input function to take those two lines of text and put them into a demo file, into a data file called csvfiles.txt, which we'll be using when we get to Linux in a moment. So if we now open this folder and have a look at it, we have created a folder with foo.dialog. If I double click on that, it brings up a text editor. I can choose any text editor I like. If I go to the demos folder, I have the CSV files with those two lines of text in that I put. Yep. And now, bring up my crib sheet here. I need to now push this data back to the internet. So I'm going to say git add my changes, git commit with the message first noodle. And then I'm going to say git push. And that will push my changes up to the internet. Right. So now we're ready to go over to Mary's Linux machine. And I have to ask her, well, do you have, there are two really important components we're going to need. She's going to need Git that I had installed, that I used to push the stuff up to a repository on the internet so she can pull it down onto her Linux machine. And she can, if she doesn't have it, I think these days very few Linux machines won't have it. She types, it varies a little bit from one Linux machine to another, but typically one line. And then the really important component, the one that this talk is really about, is something called Docker. And there's a couple of lines, there's one or two more lines than this, but these are the important ones. So install Docker, add the Mary user to the Docker Linux user group. You need to log out and log back in again, and then Docker is installed and running. Install Dialog APL. We'd like, you can do this on the Raspberry Pi. You can't currently do it on Linux. We're hoping once we have the licensing sorted out that you're going to be able to do that. But it doesn't really matter because this magical Docker thing is going to make all of this work without installing Dialog APL on her computer. So there's a little repository with some script files that she needs that she can get just by doing a git clone of Docker utils. And then she needs to clone the repository that we just built. And instead of this D18 Mary that just contains 2 files that I created, I've actually created a whole bunch of stuff that I'm going to demo. So there's a more comprehensive repository. So she's done all these things. And now we're ready to go over to her machine. So she can start playing herself. So she logs into her virtual machine. And she's done the git clone, so if she does an ls, she can see that she has D18 demo. And it's got noodle and demos, and it's got a few other things that we're going to look at in a minute. Now, she doesn't have Dialog APL installed, but she has the script Dialog C for container. And that's a script file that takes as its argument the folder that she wants to work on. And this very short command line is now going to do a number of pretty amazing things. First of all, if the Dialog Docker container containing version 17.1 alpha isn't present on her machine, it's just going to go and get it. That would take about a minute, so I'm not going to, I've already got it. This is going to start instantaneously. It's then going to launch the Docker container, which is like starting a completely new computer, really, as a virtual, in a virtual corner of her machine. It's going to start Dialog APL. It's going to map that folder. It's going to mount the folder D18 demo where she is now into a folder which is inside that machine. So she's going to have something called /app once she gets there, which contains whatever she passed in as the argument there. And it's not copying the data, it's mounting that folder so it can be shared between the host computer and her stuff. And it's going to start APL with a flag which says we'd like APL to act as a web server and present RIDE as a web site. It's then going to launch Firefox and connect to it. So when she hits enter, it's going to do all those things. And it's going to wait 3 seconds to be sure it's all up. It's going to launch Firefox and direct it to the default RIDE port, which is 4502. So she doesn't have Dialog APL and she doesn't have RIDE either installed on this machine. Right? If the Docker container wasn't there, it would have been downloaded, and that takes about a minute the first time you do it. And after that, She just has this environment where she can go in and play with Dialog APL without having installed anything. And that's why we need new licensing, which allows, where we feel comfortable doing this. At the moment, all the containers that are out there are based on 17.1, which is like pre-alpha. It's completely unsupported. If you play with these containers, don't complain to us if they don't work. Well, actually, please do report bugs. We're very interested. Right, so what she can do now is she can type link into the root app noodle. And what that does is establish a mapping between the root of her workspace and whatever source files are in Noodle. So as a result, she has a function called foo in her workspace. And we know that it needs HTTP command. So we'll just bring that in. And then let's run foo here now on. So this is ride running in a browser, and it has, pretty much the same functionality that it has when it's running standalone. There are a few things it can't do, like it can't have floating windows. Everything has to be within the context of that, but everything works as you would expect. You can trace it. That took a little while because it went out from the Docker container onto the internet, got a megabyte of data. We can hover over variables, see what's in them, and finish running, and there's the output. So she's warming up to this. Tracer looks nice, but I'm really a fan of Visual Studio Code that we've been using at university for the last year. I think that's a very, very nice environment. Could I use that? I'd prefer to use that to edit my APL code, she says. Okay. So since she hasn't installed Dialog APL, the APL keyboard isn't set up. So we need to set that up. Fortunately, Jeff, how many years ago, Jeff, got the APL keyboards into XKB map Denmark, APL option, switching between groups using the Windows key. It's a very common key to use under Linux. And then she can call visual code, giving a folder name, D18 demo / and instead of Noodle, I'm going to open this folder called Perfected, which is where the reorganized code is. So we've got a folder called Perfected, where we've split the business logic of counting the digits, taking in a character vector as the right argument, from the interfacing stuff of calling HTTP command, get, checking the return codes, outputting an error message, or calling count digits if we manage to get some data. And so if she were to say that this is very good and she'd like an exclamation point there and save it, then if we go back to our APL session and clear the workspace, and this time link hash to app perfected, and enable the Workspace Explorer, we can see that we have this stuff there. I also put the HTTP command in there so we wouldn't need to load it, just to save a little bit of time. So if I now change this and say, this is really nice, save it, then I think Visual Studio Code is actually watching it and pick up the changes in real time as they're being changed. Because although we're running in a container, these folders are shared. So she can use her favorite editor, VS Code, Emacs, Notepad, or Dialog APL's IDE as she chooses to work with this stuff. And she can run the code. That's the basic function. And if we were to unfortunately, I don't have demo working yet inside when RIDE is running inside a web browser, so I have to type all this stuff. And the thing that always goes wrong is when you type Windows key L to get quad. Since this is a virtual machine running under Windows, Windows comes in and locks the keyboard. So I was very lucky I remembered to click on the quad there on the language bar and saved a few seconds. So app is what was mounted, and in demos, CSV files, .txt, and I'll have them broken up into each line becoming a nested character vector. So there they are, and now that was just to save me typing those names. If I pick the first one, it goes out, gets the file, and returns these 10 numbers. The frequency analysis. Okay, well that's pretty cool. I could certainly use that, she says, but I have a colleague who's writing a little application in Python that might be built on top of this. How can I make it possible for him to call these functions? And to do that, you need to use another container. You need to use the Json server container from Dialog. So this is a container that contains Dialog APL and our JSON server tool for wrapping any namespace as a web service. And the argument to that is, again, the folder that you want to serve, and then the port number that you want it to run on. It's very important to type 8081 there, not 8080. Sorry? Demo, thank you. Yeah. So again, this would download the container if it's not there. Otherwise, it starts this container containing Dialog APL and JSON server and a bit of script that fires up the JSON server, points it at that folder, and then launches a web browser again, Firefox, in the surrounding system to bring up the HTTP sort of developer tool to work with this. So if I now type count digits and I provide it with some data, this web page wraps that into a JSON payload and sends it and gives me the payload back. And so this person who's using some other programming language will almost certainly have tools to make JSON requests. I mean, they are so common that you can even from the command line. There's a tool called curl. So if somebody who was just working in Linux scripting wanted to call this from a Linux script, they could write a script like this. The first 2 lines, actually the first 3 lines are just creating variables called URL, header, and data. And then this last line here is what does the business. It calls curl. This switch here says add a new line to the end of whatever returns so that you start on a new line when you've displayed the result. Include the header, which is application JSON. Include the data, which is the name of one of those files, and then call the analyze function. So if we, instead of catting that, run it, it runs that script, and we've called the JSON server from a Unix command shell. Okay, so that's pretty cool. Now, when this project gets underway, I'll have a whole bunch of interns who just need to be running this tool and collecting the results and writing some reports. Would it be possible to wrap this up in some kind of simple web interface? I think this, this HTTP thing is a little bit too primitive for them to use. Could we do a bit better than that? And, let's see, it keeps reordering these containers, or the command shells. This one, yeah. Well, I'm glad you asked that question. D18 demo /website. So open VS Code on the website folder, and in there is a single file. The logs and the sessions DCF are artifacts of having run this web server once. And what's in here is a piece of, this is my server code, or DOI code, as I think we're going to start calling it now, that Brian's going to be talking about a bit later. And what it's doing is it's adding a style sheet to give us a chocolate-colored website. It's adding a title. H1 is a header that appears on the page. It's adding an input field, which it pre-populates with the first one of those files to save us a bit of typing. It adds a button with the caption Run Analysis on. It sets up a callback to call the function onGo. And there's a little bit of styling to control the size of the buttons and colors of things. And then it adds a frequency table of empty output to begin with. And it adds a little area in the screen at the end, which is going to contain a chart. If there's a callback, it runs the onGo function, where it gets hold of the input field and calls that file. And then there's a little bit of funkiness because I'm going to try and run this on the web. So I look for a command line parameter to tell me where the JSON server that we're going to call is running. So it looks in the environment to see which IP address to use. You wouldn't have that in production. You'd have that hard-coded. It then calls, you can see it says get JSON, post, analyze, and the file name. So it's making from APL a call to the service on this line here. Yeah. So that HTTP on get JSON is like the curl call that we saw on the command line. And then it calls a little chart that does a little sharp plot chart down at the bottom. So let's see what that looks like. Let's get out of here. I hope it doesn't really mean it's going to suspend soon due to inactivity. That seems a little bit unreasonable. So this time we're going to need the my server container, which is just like the JSON server. Except it serves up a folder this time as a website. And we're going to run that on port 8080, and we're going to connect. This last parameter is optional and says I'd also like a RIDE connection to this if I want to debug the web server if there's something wrong with it. So there we are. We have the website running, and there's a chart and everything. And it wasn't a huge amount of code. So now she's pretty excited, I hope. And she says, well, that looks pretty simple, but I can't really leave my laptop running all the time so that the interns can use this. That doesn't make any sense. And of course, now this is where the cloud comes in, because all you need to do is to go to some cloud provider, start up a Linux virtual machine, install Git and Docker, as she started by doing, and then you can run this. And we'll go all the way back to Windows now and start Putty, which is just a TTY program. And as it happens, I have started one of these Linux virtual machines on Amazon Web Services before we started. I'm just logging into that here. And I've done a little bit more work here because I know I'm going to start those two things always that are going to work together. And if we go into D18 demo/service, we'll find a file there called Docker Compose YML. It's in YAML. And what's in there is just a declaration of two services, one called engine, which starts from the image Dialog Json server and maps the volume perfected into app. Another one, which is a service called website, which uses the my server container from Dialog and maps the website folder into app in the container. And then we expose two ports on the service, the web server 8080 and the RIDE interface in case we need to debug it. You normally wouldn't do that on something just running out there on Amazon, at least not with adding some kind of security, and we'll talk about that on Wednesday. And then I set this environment variable to say the engine is just, it's running as on port 8080 on the machine engine. And internally within this thing, when it starts the two, they can refer to each other by using DNS by the names that have been set up. So each one can easily see and communicate with the other machine. And all I need to do to get that to run, and this is really beautiful, is you say docker compose up. Now this is running now on Amazon, so it doesn't launch anything. But if I go here and I say AWS DC 8080, that's out in the World Wide Web, run the analysis. So all of her interns could be using this website. It's public, it's running in Ireland somewhere, in fact, on Amazon. And if something goes wrong with it and I've decided to keep this open, I would have protected it with some certificates and so on. I can go to port 4502 and tell you what, I'll type off before anybody gets a bright idea of repeating that. All right. So, what's not to like about this? So it says, okay, I need to learn more about this. What do I do? Well, you could go to try-APL, and there's a REPL there with tutorials and lessons. Or you could, from the comfort of your Linux virtual machine, you could, let's just start a, is this one still available? Yeah, you could just call the Jupyter container, which starts up something called Jupyter Notebook and serves up all of the Jupyter Notebooks that Will and Adam have been working on recently. So you could go to grading and sorting, and is Jupyter Notebooks, as you may have heard, are this collection of markup and executable APL expressions. So you could, read this, you can look at the examples, and you can modify them and execute them, and it's connected to an APL engine that's running in the background. So there you are. You can run as a web, a web service, a website. You can start the interpreter, all without installing Dialog APL at all. Back to PowerPoint for a few remarks. So, the technology that we used here, Dialog APL, Github, get used to it. Github is something that you need to get used to. We'll all be using it in a few years. It's not that hard to use. And we're going to see Paul and Gil are going to be giving presentations that hopefully will help you move in that direction. There's really not that much to it. Docker and Docker Hub, those are really the new technologies driving the cloud. It is so easy to create these containers and run them on the cloud. And I'll be talking more about how this stuff was all built on Wednesday. Visual Studio Code, I think I've been using it for a few days now. It's very, very nice. I might actually end up editing a lot of APL code there, believe it or not, although I've been using Dialog APL for decades. And of course I used the AWS EC2. The cloud is a good home for APL. The road signs even look, the road signs look more like the kind of thing we're used to when you're in the air. This is more like our kind of notation. And these Docker containers really favor lightweight, compact tools that don't need big frameworks. You just need a little bit of internet connectivity, something that can generate HTML, you're up and running. The APIs are simple, and it's like APL is coming home. It's feeling a bit, to me, like 1979 all over again, when we had very comfortable environment to run APL in. That's what that sign actually means. You're at alpha, you've got Charlie going in both directions, and taxiway alpha goes off to the right. And Docker is all you need. I've said all these things already, so I'll move very quickly here. The interesting thing about this is it seems to be equally attractive to new users coming out of university who want to get things up and running very quickly, and our biggest corporate customers who want to do all this continuous integration, deploying their application on the cloud, building these little containers containing APL to build and test and deploy your system is surprisingly easy and reliable technology. We have work to do, and Jay, if I give him any time, is going to talk more about what that is. I'll just mention a few things. We need the license, talked about that already. We need more of these public containers. It occurred to me yesterday in a workshop, we immediately need a tamstat container where anybody on Windows, Mac, or Linux can just type tamstat and the name of a folder containing their statistical data, and bang, tamstat's up and running without them installing it. We need better integration with these tools, external editors, and we really need to define what a project means to us. And there's going to be talks about that as well. One of the most important things I've realized we really need to give high priority now is this .NET Core. Because although we need only thin layer of APIs, we will need the .NET Core. And the .NET Core has become an open source, cross-platform set of libraries. And there will always be things that Dialog isn't going to put into the interpreter, and this looks like the best candidate for a library. We really need to embrace script-based applications. We'll talk about, but I'll move on. We need to learn a few things. How to need new types of maps. This is actually current. This is what's happening now. Fortunately, that front system there is going due north, and it's going to give us a miss, I think, but it might rain a bit. I don't have time to do these. They're in the program. There's lots of talks that are somehow related to these new technologies, and it's really nice to see that the work we've been doing for the last 3, 4, 5, well, you could say 20 years, is finally really starting to fit together in some things that I think are really attractive. And next year, yeah, thank you.